we're super happy to have Ed Hawkins here today to talk about his research. Just to give you a brief outline of Ed, he's a professor in climate science at the University of Reading, and he's been really involved in climate in the IPCC report. So he was co-author of the last one, and he's been a lead author of the present one. He put a stamp on climate science in many different ways. And one thing that we as paleoclimatologists really have started to use is the warming stripes, which is a very nice way of visualizing how temperatures have changed throughout history. And of course, it was something like that was presented in one of the first temperature reconstructions for the Pages 2K network. And of course, being a successful scientist, you get awards, and I think it's pretty cool, if I may say so, that Ed got this MBE, which is a member of the Order of the British Empire, which means that you have done really good stuff, and it's good to have climate scientists being highlighted like that. So again, we are really happy to have Ed here talking to us today. If you have any questions, please put them in the chat. We will take them after Ed's talk, and if there's something urgent, I will try to check the chat. So if there's something that needs to be answered straight away, I'll try to let Ed know. So without further ado, please, Ed, the floor is yours.
So thanks so much for the invitation. It's a pleasure to be here. And I guess from the outset, I should say that I'm not a paleoclimatologist. I'm not a paleo person, but I do think a lot about changes in past climate, mainly from instrumental data and also from model simulations, and also think about the future a bit. So Hans asked me when he invited me to talk a little bit about the topic that caused a lot of discussion within the IPCC process, which was what is pre-industrial? What does pre-industrial mean? And so I'm going to talk a little bit about that to begin with, and what the IPCC said, and try and highlight some potential developments which are coming along within the instrumental data community that may be of interest to you all, and highlight some opportunities where I think we can connect paleo reconstructions and instrumental records a bit better. So that's going to be the sort of the first half of the talk, and then I'm going to talk a little bit about a more specific way of connecting data together, and that's through a project we ran to vastly improve our rainfall reconstructions in the UK, and extending the rainfall reconstructions a long way back in great detail, and hopefully that will also be a potential opportunity to collaborate and connect paleo reconstructions of rainfall or drought with the instrumental records that we're now recovering. So it's going to be a bit of a talk in two halves, focusing on pre-industrial first, and then a bit about our rainfall rescue effort later on. So as Hans said, this is one version. He mentioned the warming stripes, and this is one version on the front slide, which shows your amazing Pages 2K data from year 1 up to year 2000, and added on is the instrumental record for global temperature from 1850 to present. So first of all, it's fantastic that the two records agree pretty well over the overlapping period, and obviously there's been a very rapid change over the last 20 years, which isn't captured in the paleo reconstructions yet, and we have the instrumental records for that. But it's wonderful that we can now connect these two data sets together in this way, and of course it's great to also be able to look a long way further back in time and understand the variations that have occurred in the past as well. And it was extremely useful to have all this information for the IPCC report, and a figure like this appeared in the summary of policymakers, showing how important it was, I think, to understand changes in past climate. So two particular aspects I'd like to draw out of this. So first of all, I've now added an axis, a scale onto this graphic on the right-hand side, showing how much warming we've actually had. And I've also marked on two points. So one is the potential start of an instrumental series. So this is a little bit I'm going to talk a little bit about. How far backwards can we extend the thermometer records to improve this overlap extend this overlap between the paleo data and the instrumental data? And that potential start is around about 1780. And I'm going to talk a little bit about a project we are doing to try and produce a data set going back that far for land and ocean. So that's one part. And I think that will be really useful to have that overlap, increased overlap through a very interesting period in our climate history. And the other point marked here is the word pre-industrial. And what does that mean? It's obviously of relevance for policy, as we'll discuss in a moment. But I think that should have a little bit of uncertainty around it about what exactly we mean by pre-industrial, how much has the climate warmed since that time already, and how does that affect policy making and the UNFCCC process, such as the Paris Agreement. So that's the little bit that Hans asked me to talk about, which I'll try and highlight as well as we go along. So that's where we're going to start. So there's a famous picture from the COP21 Paris Agreement meeting. And of course, the Paris Agreement states that they want to hold the increase in global average temperature to well below 2 degrees above pre-industrial levels, and pursue efforts to limit the temperature increase to 1.5 degrees above pre-industrial levels. So this is obviously a very important part of the Paris Agreement. You'll note that it doesn't really make many specific definitions. It's deliberately vague, and that's how these agreements tend to be written. They're not overly precise. They tend to be deliberately a little bit vague, but that is frustrating for us as scientists when we want to be ultra precise about meanings. For example, it doesn't say whether it means annual temperatures. That's kind of assumed, and it's also assumed that this is the long-term average rather than any individual year. But again, that's not specifically stated, but it is kind of assumed. And so we have to make some assumptions if we're going to interpret this phrase in a scientific manner. So there was lots of discussion when we wrote IPCC AR6, involving probably people on this call and on this webinar, as well as many others, about what does pre-industrial mean in terms of the Paris Agreement and in terms of calculating how much climate's already warmed, when we might cross particular temperature thresholds, how much more carbon can we burn to avoid reaching those thresholds. So these are very highly policy relevant questions, and we need to define a baseline from which we're starting counting. And so this definition of pre-industrial is critical in that discussion. And there were lots of discussions amongst lawyers as well as the scientists about this interpretation. And it became clear, I think, that in IPCC AR5 in 2013, the global average temperature during 1850 to 1900 was used as a baseline to try approximately represent the pre-industrial period. And so that was adopted then, and that was essentially the state of the science when the Paris Agreement was written. And so the lawyers suggest that if it ever did go to a court of law, the way that the pre-industrial wording would be interpreted in the Paris Agreement would be the state of the science at the time, which means that 1850 to 1900 is kind of the standard from which everything has to be baselined. Now, we'll discuss a little bit about that. Scientifically correct, perhaps, but that's the legal interpretation. And that's why the IPCC special report on 1.5 degrees, SR 1.5, and also the latest IPCC sixth assessment report also adopted this interpretation and used 1850 to 1900 period as a representative pre-industrial. So this is only for global temperature we're talking about here. So that's kind of what's been adopted. But there are many sort of other scientific and definitional issues which we might want to think about. So the IPCC formal definition of pre-industrial is the multi-century period prior to the onset of large-scale industrial activity around 1750. So this was written a long time ago, I think probably for the second assessment report. So it's quite an old definition. There was quite a lot of discussion about whether we should try and change this definition. Is it still appropriate given the state of the science? There was certainly a lot of disagreement about and discussion about changing it, and ultimately it wasn't changed. But so that is the official IPCC definition of pre-industrial. And I think this was probably written when there was less understanding about how the climate had changed before 1750. So that may have influenced some of the wording in that definition, but that's what's written down. Other things that have changed since the fifth assessment report is that the revised instrumental temperature data sets, so the ones that tend to be used from 1850 onwards, they show a larger change over the historical period than they did in AR5. And that's because of improvements in our understanding of how observations were taken, more observations being added, and accounting for areas where there are less observations. And that's revised upwards the amount of historical warming by about just under 0.1 degrees C when trying to do as close a comparison as possible. So there was warming that occurred, but we didn't know about it at the time of AR5, but that has been better accounted for at AR6. And it also became quite clear, I think, and has probably been for a while, that there was already some human-induced warming which occurred before 1850, so before our baseline period, because greenhouse gases had already started to rise by that point. And so there's likely some additional warming which is not accounted for in the current definition, potentially. And so scientifically, I think we want to try and better understand that. It might inform future UNFCCC policy agreements. I think we certainly want to understand it from a scientific point of view for issues such as climate sensitivity and so on. And obviously the period between 1750 and 1850 is a very interesting period in terms of volcanic eruptions and variability and so on. And so I think understanding that period is a real opportunity where the paleo and the instrumental community can work together a bit more than they have done in the past. There's a kind of a separate discussion about whether any of this additional accounting for warming in the past actually matters for any assessments about climate change impacts, and what that might mean for any temperature thresholds we might want to avoid. And again, there's a lot of subtlety about how a lot of these assessments are done. And the answer is probably this doesn't matter very much for climate change impact assessments. And that's mainly because virtually all climate impact assessments, when we're thinking about future changes, already use a modern baseline for their assessments and scale backwards to estimate what the change from pre-industrial might be. But the change is not calculated relative to the pre-industrial period. It's calculated relative to a modern period. So any warming which occurred before that doesn't really matter for when an impact might occur. That's rather subtle and it caused a lot of discussion, but essentially any changes in historical warming won't really matter for when we might expect certain impacts to occur. So I think there are some scientific opportunities here to use paleo records and extended instrumental observations to address these issues and understand the pre-industrial period a little bit better. So in IPCC AR6, the assessment was kind of split into two. Chapter 2, if you want to read chapter 2 of AR6, discusses the instrumental data and the changes relative to 1850 to 1900, and that's summarized in this figure, which actually appears in chapter 1. So this shows the 4 different global temperature data sets which are used in the assessment of observed instrumental change. So there's 4 black lines showing the 4 different data sets. They all agree pretty well, not perfectly, but they agree very well over the historical period. And you can see the assessed changes in global temperature from 1850 to 1900 up to various different times in the past. So 1.1 degrees roughly up to the most recent decade. And you can see other reference periods that are highlighted there as well. So that's what was used. That 1.09 value for 2011 to 2020 was what was used as the kind of warming to date relative to the what is representative, thought to be representative of pre-industrial. So separately, there was a separate assessment done for what happened before 1850, and that's shown by the grey shading. There is a likely range for global temperature change relative to the period around about 1750. And that was a separate assessment which wasn't accounted for in any of the subsequent assessments about warming thresholds or carbon budgets or anything like that. But that range goes from -0.3 to +0.1. So the assessment is that there was a little bit of warming which occurred between around 1750 and 1850 of around about 0.1 degrees, but it's quite uncertain. And so that uncertainty is one reason why it's not included. But that's what the assessment, that's where the assessment was split up. So I've kind of said some of this already. So what happened before 1850? So that's not really included in any of the headline assessments. That uses the instrumental record only, and that's the assessment in chapter 2. And then chapter 1 has this separate assessment saying that global surface temperature increased by 0.1 plus or minus 0.2 degrees between 1750 and the assumed pre-industrial baseline. And importantly, there's an anthropogenic factor likely to be responsible for 0 to 0.2 degrees. So we think it likely that there was some additional warming due to human activity which occurred before the pre-industrial baseline, but that's not included in the assessments, the headline assessments. And so in that chapter 1, there's a cross-chapter box which discusses this issue in detail and discusses the forcings which occurred between 1750 and present day, splitting it out between greenhouse gases changes in other human activities, mainly land use change and aerosols, so sulfate particles and black carbon and other anthropogenic agents such as those, and also the natural factors. And you can see that the large volcanic eruptions very visible in the natural grey line, picking up there. So greenhouse gases did increase between 1750 and 1900, and also that's been slightly offset by changes in land use and aerosols which cooled slightly over the same period, and they didn't quite fully offset each other, and so there is a positive radiative forcing in the pre-industrial baseline of around about 0 to 0.3 watts per meter squared. So that was the assessment in the IPCC report. And so there have been a few studies trying to which feed into that assessment, I guess. So that assessment overall feeds in all kinds of information. It feeds in information from pages. So for example, the pages 2K temperature record was used as one line of evidence in that assessment, and the change in pages is roughly 0. So I think it's slightly positive, but only slightly. And so the pages 2K reconstruction fed into that as one line of evidence in that assessment. Other lines of evidence included some of the very early instrumental records we have, such as Central England Temperature, CET. And it turns out that Central England Temperature is actually a pretty good proxy for global temperature. If you look at this figure from a 2017 paper, obviously there's lots of variability on the small scale of Central England, but the long term, if you smooth out both lines quite a bit, they're actually very, very similar. And so actually where Central England happens to be is a pretty good proxy for global temperature if you smooth it out. And so you can think about extending that back in time and trying to come up with an estimate, a long-term average, for example, for how much things have changed. So that's one other line of evidence you can use, is some of these very early instrumental records. Of course, they have large uncertainties and potential biases in observation practice and so on, but they're one other line of evidence we have. And we also have model simulations. So there's a couple of examples here from Andrew Schurer 2017 paper looking at model simulations. This example happens to be from the year 1400 up till now. and they've split out the simulations into greenhouse gases and volcanic influences and also solar influences, and also everything together, the all-forced simulations. And these again show that there was probably some warming or some warming which occurred due to greenhouse gas changes from about 1750 up to 1850. So there's already some warming that's there, according to the model simulations anyway, in the greenhouse gas simulations, and also probably in the all-forcing simulations as well. And obviously there's a large influence from the volcanic eruptions at various times as well. So that's one of the other line of evidence. And there's a similar figure in Owens et al. 2017, which was mainly focused actually on the what's called the Little Ice Age, which I know is a term which we don't actually use in the IPCC report anymore. But this was actually written for solar physicists to try and persuade solar physicists that the sun is not everything, and it's not just the sun that caused the cool period around the 1700s. There's all kinds of influences from volcanic eruptions, from orbital changes, and from land use changes as well. So there's lots of factors which are important. It's not just the sun, as many solar physicists tend to suggest. So there's all these different lines of evidence which come together. And I think there's opportunities going forward from now about how we might improve some of these estimates and combine the data a little bit more closely together. So I'm part of a large project called GLOSAT in the UK, and that has its aim is to to generate a instrumental air temperature reconstruction back to the 1780s over both land and sea. And this hasn't been done before. Air temperature over the ocean is not something that's used very much. It's mainly the sea surface temperatures which are used for reconstructing past changes over the ocean. But there's actually more air temperature observations than sea surface temperature observations before around about 1900. And so you can only reconstruct before 1850, certainly with air temperatures over the ocean taken on board ships, rather than the sea surface temperatures. So that requires a bit of a change of thinking, of using air temperatures rather than sea surface temperatures. So there are a lot of existing digitized air temperature observations over the ocean, and of course over the land as well, but we're going to add to those. We have projects to transcribe old logbooks. There's one example here from a ship from the UK Navy in the 1860s on the left, and we're about to launch a citizen science volunteer project in the next few weeks to try and transcribe some of those observations and digitize some of those observations to add to our data sets. And on the right hand side is a logbook from a location in the UK. This is from 1828 from the city of Exeter. Again, this data has not been digitized, and they've got 3 times daily temperature observations all the way back to about 1815 in these logbooks, which haven't yet been digitized. So there's all kinds of efforts that are ongoing and could be extended and expanded to try and improve our instrumental data sets further back in time, especially. But there's also gaps in the more modern period as well, and so particularly in the Pacific. And we are involved also in a project which has been run by Kevin Wood from NOAA, which is also rescuing and recovering new temperature data and pressure data recorded in USS logbooks, USS ship logbooks, with a particular focus on World War II period in the Pacific, where there are quite large gaps in our existing data sets. The Pacific is not as well represented as other ocean basins, and so we want to try and fill some of those gaps. And there's actually been lots of interesting history associated with this. So those who are aware of this will obviously know of the Pearl Harbor attack, and so many of these logbooks actually start with the Pearl Harbor attack and go on from there for about a decade. And so we're rescuing a lot of the meteorological data taken in the aftermath of that, when the ships started to sail across the Pacific and take observations wherever they went. And so it's a rich source of data. Here's one example: the USS Salt Lake City sailing around the Pacific in 1941, and having that data now will fill in lots of gaps in the Pacific, and there are about 20 or 30 other ships that we now have data for, which will also be added to the data sets. So if you've got proxy data in the Pacific, For example, from this time, there's going to be more instrumental data to be able to compare to. And so just to finish this little section, this is one of the figures from the IPCC report, again from chapter 1, describing the state of data from both instrumental records and paleoclimate records. It's trying to summarize where we are in terms of data availability. There may be quibbles about the length of lines or width of certain lines at certain points, but this is an attempt anyway to try and summarize how much data we have for different components of the atmosphere, ocean and land from different sources. And again, trying to expand and extend backwards some of the instrumental records to meet the paleoclimate records and have a larger overlap, I think is going to be a key opportunity over the next couple of years. So just to summarize this first part, I think there are opportunities to better understand the pre-industrial climate by better integrating paleo and instrumental data together, as well as model simulations. So as I said, the GLOSAT project will produce a gridded data set of air temperature changes back to the 1780s over land and sea. It will be focused, because of the availability of data and where the ships went and so on, over the east coast of the US, the North Atlantic and Western Europe. But there will be data from other parts of the world as well, wherever the ships happen to go and wherever we can find land station data. And so we continue to expand our instrumental data coverage all the way from the 1780s up to 1950s. I showed the Pacific example. There's also we have a lot recently. We found 4 million images of data taken in Africa up to from the 1900s up to 1950s or so, which we have no idea yet how we're going to digitize 4 million images worth of meteorological data. But they're there and available. And so if anyone has any proxies in Africa, then there may well be instrumental data nearby, which is still sitting on paper, or which we now have images of, which could be digitized and added and incorporated with any analysis, for example. So there are opportunities again there, I think. And of course, there will be continual updates to our model simulations. GLOSAT is going to have a particular focus on the 1750 to 2000 period. So again, that will continue to develop. And one other development that was in IPCC AR6 was that it highlighted, I think probably for the first time very explicitly, the risk of a sequence of large volcanic eruptions in the summary of policymakers. This the very high-level document, it said there is a risk of a sequence of very large eruptions which would have enormous effects on the climate temporarily. And so I think better understanding the impacts of volcanic eruptions, I think, is also an opportunity. And again, we're going to have new instrumental data covering the very interesting volcanic period from 1800 to 1850 to compare with the proxy data that's already there. And I'm sure there's more proxy data on its way as well. And of course, this all has relevance to international climate agreements as well. So that's the kind of the first half of the talk. And I think there are some opportunities there. So if anyone is interested, I'm very happy to chat offline or afterwards about some of these opportunities. And I may have, maybe a lot of this is already going on already, and I'm not aware of it. So apologies if a lot of this is obvious already, but I think there's some opportunities. So the second half of this presentation is going to focus on something completely different, but it's all, again, hopefully will highlight the potential connection between instrumental and proxy data that we might improve. So this is about a project we called Rainfall Rescue, which I have to say thank you to the 16,000 volunteers who we'll hear more about in a moment, who enabled this project to happen. And so this opening picture is a flood in Reading, which is where I live, in 1947. My house is in this photograph. It's very close to being underwater. It wasn't quite flooded in this event, but it was very close to being flooded. And so this is quite a close to home event. And many of the flooded areas are now built on. And so if this flood happened again, there would be very large areas of Reading where people live, which would be flooded. And so understanding the risk of these types of events is obviously very relevant. And so obviously floods and droughts have enormous impacts. And so more rainfall data will obviously help assess risks of those types of events. And as I said, we can hopefully integrate better with some of the paleo evidence as well. So on that particular aspect, again, I'm not a paleo expert, and so I may be misusing these data sets, but you can certainly look at the Old World Drought Atlas and for over the England and Wales, for example, and when you do that, you find a very significant drought from about 1750 to 1850, which is the standout event really in the Old World Drought Atlas over this particular region. So, if that were to happen, compared to the modern day records, that would be very, very significant drought for this part of the world. And I'm not sure our water resources would survive something like that. So it's obviously very significant and important to try and understand. And we obviously have instrumental records from rain gauges of rainfall. So obviously the PDSI, the drought index used in Old World Drought Atlas, is not rainfall, but there is some connection there. And the rainfall estimates we have currently start in around about 1860 in detail, and they show some similarities with the Old World Drought Atlas variations. And there is a very small number of rain gauges built into a data set called England and Wales precipitation, which goes back to about 1760s, and that shows something completely different for summer rainfall than is seen in the Old World Drought Atlas for summer reconstructions of drought. So obviously the Drought Atlas is not just all about summer rainfall; it's about other aspects as well. But I thought this disagreement or potential disagreement was also interesting to highlight. But there are only a very small number of rain gauges used in that reconstruction, and there's a lot more data, as we'll talk about now, potentially available to reconstruct that period in a lot more detail than we have been able to in the past. And again, trying to potentially link these two records or these multiple records together. So rainfall recording started at this old mansion house called Townley Hall near Burnley in the northwest of the UK. There's a painting by Turner of Townley Hall at that time. And here is the first publication of rainfall being recorded by a rain gauge. It was published in 1694 by Richard Townley, and it shows the amount of rain that fell every month from January 1677 up to December 1686. And so we do have a record of rainfall going back that far. How useful and accurate this is, I think there'll be some question marks about that, but we do at least have an estimate of how much rain fell all the way back that far. He went on to record data for another few years. He was actually away from his home for a couple of years for a lot of the time, and so didn't record any data in 1687 and 88, but he then continued again up to 1693. And so all of that data does exist. But it's only one site in England. But of course, after that, things started to expand and people got interested in recording the rain. We get a lot of rain in the UK. It varies a lot. It's often a topic of conversation. And so it was popular to observe as well, as we'll see. So the existing rainfall data sets we have at the moment for England and Wales. So we have an annual rainfall series called England and Wales from 1766 to 2020. Again, showing very interesting variations, times of lots of rain and times of much less rain for a few years. But again, as I highlighted, the early part of this, the first 100 years or so, is based on very, very sparse data indeed. And so we want to try and improve some of those reconstructions because we know we can. And at the other end of the scale in the UK, we also have a gridded rainfall series at 1 kilometre resolution, which the Met Office produce, the UK Met Office. And so we have estimate every month from 1862 onwards. And here an example, a couple of months. February 2020 was a very, very wet month across the UK. It wasn't the wettest month ever. That was October 1903, which is the map on the left, showing the amount of rain that fell in that month. You can see the black dots, which represent the rain gauges that were used to create the gridded reconstruction. And you can see that obviously the number of rain gauges has dropped off enormously back when we go back to 1903, but there's certainly enough to make a good estimate of the rainfall across the country. But we'd like to improve that a lot, and when we can do that. So when we look at the number of rainfall gauges used in those very detailed reconstructions of the UK, there's a couple of very interesting features of the number of rain gauges used. The first standout thing is that the number of rain gauges jumps enormously in 1961. And of course, it's not that we suddenly started observing rain in 1961. It's just that after 1961, all the data was digital, and pre-1961, it was all handwritten. And not that, and the handwritten stuff has not yet, or hasn't yet been transferred into digital data for us all to use. There's obviously also been a drop-off after about 1970, 1980. Less people are just measuring the rain. Now, some of these are still volunteers recording the rainfall. Many are official observing sites as well, but there has been a drop-off over the last couple of decades. So there are around about 3.5 million monthly observations that go into reconstructing the UK rainfall at the moment. And as I said, the rest of the data is or was still on paper. So this is one example of one of the sheets of paper that some of the data is on. This is an example from Reading. This is the closest one of the closest rain gauges to my house, showing the amount of rain that fell during the 1890s at that location. It helpfully has the latitude and the longitude and the observer's name and the location. And so this is, gives us a very good idea of where the rain gauge was and how much rain fell in every month. And that data is not in the database used by the Met Office at the moment. And there are 65,000 sheets of paper like this that were sat in the Met Office archives, which hadn't really ever been used. And the Met Office then scanned them all, so they now had 65,000 images instead of 65,000 sheets of paper. And there are around about 5 million observations on these 65,000 sheets. So computers are not up to the task yet of reading these tables automatically. We've asked a lot of people, and the technology is not there yet. It probably is coming, but it's not there yet. So we have to think about other ways of trying to digitize this data so we make it usable. And so when the lockdown started in the UK in March last year, we decided we would try and do something about this. So we built a project called Rainfall Rescue, and there's a very helpful website called the Zooniverse, which provides the online web infrastructure to build projects where you can ask volunteers to come and help. So we asked the public for help. So we built the website, which enables you to show a volunteer an image. So there's an example image here on the left-hand side of one of the sheets, and ask very simple questions about what the volunteers see on that sheet of paper. And so we asked them to type in the amount of rain that fell in a particular month of a particular year. So we had thousands of volunteers come to help to type in these 5 million rainfall amounts. It's a lot of typing. This would take someone several years, one person doing this, probably 6, 7, 8 years, I suspect, to do this for one person, which is why you need to outsource it to lots of volunteers. And quite remarkably, we had 16,000 people step forward to do something and to help us out. And we completed the transcription of all 65,000 pages in just 16 days. So that's essentially more than 5 years, probably many more years than that, a volunteer effort in just 16 days. And it was coincided with the lockdown, when many people were at home wanting distractions, wanting potentially something to do if they'd been put on furlough or taken out of work. And so there were lots of people there who potentially had more spare time or wanted a distraction from what was going on in the world. And they all stepped forward to help, which was amazing. And so they ended up typing 5.28 million monthly observations of rainfall, which was more than the entire existing Met Office database, which we put together over decades. So in 16 days, we more than doubled the existing database, which had taken several decades to put together. And at least 4 volunteers typed every single column to try and pick out typos, and we had more than 99.5% consensus on the values that they typed. And so we have great confidence in the values that we have available to us now. But that's not all what we need to do. We need to then put the different sheets of paper together. And so obviously we have different sheets for each decade. And this is one site where there are 6 sheets of data representing different decades. And we have to put those sheets together, concatenate the data, and produce a time series of the rainfall at this particular site in Reading. And so we have a site here in Reading with data now from 1910 up to 1960 to add to the database. That's quite a task in itself. And so actually we've had a small group of very dedicated volunteers who are still helping, still identifying these different pages to join together and produce the long series which we can add to the databases. And so they've been helping us now for about a year, which is amazing. And so we've put together about 3.5 million out of the 5 million observations into long time series, which we can now use. And so I showed a version of this graph before with the orange line representing the existing data in the database. And the black line is now what the database will look like, or that's the data we've recovered from this project. And so we've now got more stations in the 1900s than we do today to cover the country. And we have more data back in the 1830s than we previously had in the 1870s. And so we can extend a long way back some of the time series and the gridded data that we can now make available. And this data covers the whole country of the UK. So we have data from the Outer Hebrides, the Orkneys, all the outlying islands of the UK, as well as parts of Ireland, the mainland of Ireland as well. So you can see it covers the whole country in great detail. And as we step back through time, there are fewer and fewer rain gauges. But even back in 1816, we have a large number of gauges covering, large parts of the country, not the whole country, but large parts of the country. And so we can certainly reconstruct rainfall over regions of the country all the way back to the 1800s, and potentially even slightly earlier. So we can now produce a rainfall series all the way back to 1836 for the whole of the UK. And here's an example of those time series for each season. The data we have agree well with the existing Met Office database where we have the overlap, but we can go further back in time. And there's lots of very interesting dry periods. So the very dry winters, for example, in the 1840s and 1850s and early 1860s, which we can now reconstruct and start to look at in terms of what was going on perhaps in terms of drought. Just to give one example of that, here is the summer rainfall variations in one particular river basin, the river basin I live in, the Thames Basin. And previously we could reconstruct rainfall variations back to 1862 in this river basin, and potentially there was a small decline in rainfall over that time. We haven't had any really wet summers, not many wet summers for a while, but they occurred earlier on in the series. But when we go back to 1800, again, it doesn't suggest there isn't much of a long-term trend in summer rainfall, but all of the wettest 6 summers occurred before around about 1900 or so. So maybe there's a hint that something's going on with the rainfall, but it's not a very large signal. But this is very helpful to understand long-term changes in rainfall in the UK. And perhaps summer rainfall is not something we should be worried about changes in, for example. For winter, it's slightly different. The extra 60 years we can put together for the Thames Basin are all remarkably dry overall. And so we do seem to have a very large winter rainfall drought in this part of the country for about 50 or 60 years, which is very significant and larger than anything we've seen in the rest of the instrumental record that we have. And so we're certainly going to think more about what that means for water resources and so on. I'll skip over a couple of these. But just to highlight also that there is another source of information that we have, which is the reanalyses. So many of you will be aware of what a reanalysis is. but it essentially is a weather forecast model run as if it was making a forecast back in time. So the one that we're using here is the 20th century reanalysis, which goes back to 1836, produced by NOAA, and they essentially do very short-term weather forecasts every 6 hours from 1836 up till now, and use that data only using surface pressure observations to constrain the atmospheric circulation. But obviously the weather model then spits out temperature and rainfall and everything else associated with the climate. And so you can examine the changes in rainfall, for example, in this reanalysis, and compare that against our instrumental data. And these two data sets are completely independent. There isn't a single observation which is used in both. So one only uses the weather forecast model and pressure, and the other one only uses rainfall data. And even all the way back to the 1830s, the agreement on the variations from year to year is remarkable. So we're very, very confident in the variations of summer rainfall over the UK all the way back to the 1830s now. So I think that's a real plus, I think, for trying to understand summer variations in rainfall, which of course may be very interesting for paleo reconstructions as well. For winter, the situation is not quite as clear. The reanalysis shows a long-term decline in winter rainfall from 1830s onwards, which isn't present in the instrumental observations, and we don't understand why that is yet. So that's something under investigation. So I guess just to try and summarize then the last little bit of this talk about the rainfall is that we do have enormous archives of undigitized meteorological data. There's at least 1 billion observations back to the 1800s and earlier stored just in UK archives. And obviously there are similar archives all over the world. And we've had amazing volunteers who have been helping us out over the last few years in digitizing several million rainfall weather observations. So the rainfall one was not our first project, that was our 4th project we run, but it was the biggest that we've run so far. And so the volunteers are amazing, amazing resource for helping us out and improve our reconstructions. So we are improving our reconstructions for floods and for droughts, and try and better understand risks. And it would be fantastic if we can build in some more collaboration with the paleo evidence as well, this community, to try and think about overlaps and collaborations and connecting these two resources together. Thank you.
Thank you very much, Ed, for a great talk. I really like this kind of talks where you kind of try to connect and with the colleagues and also give give these ideas of, I mean, not just collaboration, but also maybe this could be something that could be done in other countries. As you say, there's so much data that is sitting there just waiting to be digitized. And I actually had a discussion with a colleague here, is thinking about, would this work everywhere? I'm not sure it would work in Sweden, for instance, that people would, be bored and do this. But you never know, actually.
And I think, wherever these projects have been run, they've had enormous success. There's been projects in Australia and New Zealand and the US now as well. And I know Denmark also have plans, and Italy also. And you'll find people interested in the weather everywhere, and people interested in helping out with science. And I think many of the volunteers we have maybe not had opportunities to be involved in science earlier in their lives, and so want to do something useful and use the talents they have. I mean, the volunteers that we've had involved over the last year are incredible. They've got amazing skills, technical skills, which they've applied to this problem and made it far more efficient, and made it possible to achieve what we've achieved.
Great. So yeah, we'll see about that. And now we have questions coming in, and we have one here. So Rajiv, if you wanted to ask it, or do you want me to read for you?
Ed, is there a way to constrain the volcanic eruption contribution to the global temperature prior to the instrumental data?
So I get it may well be a question for the sort of Rafi and for Daryl and others perhaps, but certainly there are signals of the volcanic eruptions, the response to the global temperature response and the regional temperature response to the volcanic eruptions in the pages database and data. So we can certainly see that. It would be amazing to have independent checks with new instrumental data for the same eruptions. That would give us more confidence about the effects and more details, and potentially even have rainfall responses to eruptions as well. I mean, it's not just temperature that we're worried about. It's what would a volcanic eruption do to global food security, for example. So it's rainfall as well as temperature that we would be worried about. And so again, I think we need to try and bring all the data together where we can to understand that, because it is a risk. We will get more eruptions at some point, and the policymakers need to understand what the consequences might be.
Great. Do we have any more questions? So just feel free to chip in. So while you're thinking, I'm a bit interested in the pre-industrial, and do you think it would be worthwhile to try to look at the pre-industrial in a regional way? Because obviously you would have different times of emergence of the anthropogenic signal, but also the transition from pre-industrial to industrial climate. So what's your thought on that?
No, I think that would be really interesting. I agree. So the assessments made in the IPCC about pre-industrial are all about global temperature, because that's the key metric that we're going to be judged by. But undoubtedly, changes on a regional basis are what matters. And in many areas, those changes are very, very clear, because the variations from year to year are very small. So this comes to the topic of emergence. And so understanding the changes they've already experienced in those regions is critical. And so understanding the pre-industrial climate there would be really interesting to know. And it's not just temperature again, of course. It is things like sea level and rainfall. There's actually a volunteer project at the moment rescuing sea level tide gauge data to enhance our understanding of sea level changes. So there's data for everything buried in logbook somewhere, if we can just dig it out, and it will help answer all these questions.
Yeah, great. Paul, you raised your hand, please.
Yes, I have. Yeah, this is kind of connected. Thanks, Ed. Good pair of talks there. Very, very interesting. I'm just wondering, when I look at these, these long rainfall records from individual sites or even for a whole country, it's very difficult to see the emergent global signal of anthropogenic change in those. Do you agree with that?
Certainly, I'll speak most about the UK, because that's where I know most about, but certainly in summer, we don't really have much of a signal. And that's actually consistent with our expectations. If you look at the model simulations, for example, of the past, and even for the future, there isn't much signal for summer rainfall changes over the UK. If you go further south in Europe, you do see some summer signals, summer drying signals, but particularly over the UK, there's not much of a signal. Where it is very clear there is a change in the observations and in the model simulations, so our expectations, is in winter rainfall. Winters are definitely getting wetter, particularly over the northern parts and western parts of the UK. So that's very clear in the observations and in our models. But no, climate change doesn't mean everything changes. It means some things change, and for rainfall, that's particularly seasonal in the part of the world where the UK is. In other places, it'll be very different.
No, absolutely. And there were one or two of those plots for winter rainfall which did seem to show that. It's just that the way it's plotted without any smoothing in there, you have to do it by eyeballing the peaks and troughs, and that I find that a little bit more difficult.
I agree. Yes, we certainly do have to look over long timescales and smoothed. I think part of the motivation for plotting every year is to highlight how much the rainfall varies from year to year. We know that internally, but it's also very important to highlight that the changes we are experiencing, the fact that you can't see them by eye easily, is important information. You know, the changes are important, but the fact that the time series is very noisy, and we don't expect every year to be wet, even in a wettening climate. And I think that's important to highlight as well.
Yeah, thanks.
Any further questions? Yes, Andrew, do you want to ask it yourself?
Okay. Yeah, so Andrew's asked about the disagreement in the winter rainfall between 20 CR and the instrumental data. We have a couple of hypotheses. One hypothesis is that the rain gauges under catch, particularly in winter, because of snow. Not all the snow was caught probably by the old designs of rain gauge. And so that may cause a slight underestimate of the rainfall amounts as compared to the reanalysis. We don't think this is a huge effect because we also see it in the southern UK in spring and autumn where there's no real snowfall. So that's clearly not the only effect. Whether it's something to do with the SSTs driving the reanalysis, that's another hypothesis that, you know, maybe the SSTs, although the variations from year to year are spot on, which are amazingly, they agree amazingly well, the interannual variability, even in the winter, but the trend, maybe there's something, the trends are not quite right in the SSTs and the reanalysis. That might be one cause of the explanation as well, but I'm very happy to hear about other plausible explanations because it's a bit of a mystery still.
Great. Nikita, you have your hand raised.
Yes, can you hear me?
Yes.
Yes, it was a really interesting talk. Thanks for that. I was wondering about the Reading photograph that you showed, you know, with the flooding around your house. You could reconstruct the data for how much it rained, but the flooding could also be just land use, right? Just something constructed badly. So if you wanted to reconstruct flood events in a particular place, how do you differentiate between rainfall amount and just as a way to reconstruct? That's
a great question. So actually, even so, that flood event is even more complicated than that actually, because that winter, the 1946 to 47 winter, was incredibly snowy, and so actually the flood was caused by a lot of rain, but actually a lot of it was due to melting snow because it suddenly warmed up and a lot of snow melted, and so there was more rain and more snow melt, and so that was one of the reasons for why the flood was particularly bad. And also, there were obviously changes in land use and how we store and let rain travel through the river system. There are flood models, so people model rivers and river catchments, and so we're actually hoping to start a PhD student looking at some of the sort of the simulated and modeled river flow data using some of the catchment rain water models to try and simulate real floods and droughts, taking all account of all of the factors such as snow and land use change and everything else. So yeah, so going all the way from rainfalls to floods is complicated. Obviously we need the rainfall data to start with, and then hopefully we can move on from there.
Well, sounds good. Thanks.
Great. Then we have a question from Matt. Along with the historic data, are you able to find info on the historic instruments in order to understand biases? Yeah,
that's another great question. And I think the answer is sometimes. I see Tim Osborne's on the call, so he may be able to chip in as well on some of this. We certainly do have lots of information in many places, but not everywhere. We continually discover occasionally. So, for example, we found recently some ships which have 2 or 3 different types of instrument recording simultaneously, which is very helpful because it allows us to try and understand potential biases when they switch from one to another. And so having parallel measurements like that is really useful. There are known parallel measurements on land, and we've now started to find more and more on ships as well, which is really helpful for understanding sea changes over the sea. and many of the ship's logbooks do contain very detailed metadata about the instruments used and where they were sighted. We don't always have that information, and again, on the land stations, again, sometimes we have detailed metadata, but many times we don't, and we have to make assumptions and judgments and so on.
Yeah. So, any more questions? I was just thinking, I mean, regarding floods or drought, so I guess you need to go down on a higher resolution to have daily observations. I mean, would that be? I guess you need a kind of a different scale of citizen science to get those records. But would that be possible? You know, eventually.
Yeah, I mean, it's definitely possible. So, we would ideally need to have the daily measurements. And of course, they do exist in many cases. So there is a separate entire shelving unit in the archives in Exeter in the Met Office, which contain what are called the climatological return documents, and they have the daily observations included. But that scales up the problem of digitizing it by a factor of 30. And that makes it extremely challenging to think about doing in terms of, and so the data exists, it's on paper, we know where it is, we have the images, but turning it into digital data is an enormous challenge, and it may need to wait for automatic technologies in many cases, which many people are working on, including in the UK and elsewhere.
Okay, thank you very much. It's gone 1 hour, so unless there's any more questions, I would like to thank Ed again for giving a very good presentation, but also reaching out and giving food for thoughts. And as Ed said, if you want to do something, engage, you can contact him, and hopefully this can be something that benefits pages as well. So thank you very much, Ed, and thank you everyone who's been here watching this. And one thing, I just have to remind you that we have another seminar coming up with Thomas Felix and Hussein Sayani about corals, ocean hydroclimate. So don't miss that. That's on October 13th. Yes, sorry.
Thanks, everyone.
Thank you.